Hey everyone, my name's Ben. I'll be giving a talk on decentralized finance tonight. So basically, when I first saw the event made on Facebook, I was a bit disappointed because someone came up to me at work and said, "Oh, do you want to give a talk on DeFi?" And I was like, "Oh yeah, that'd be sick." But then I saw the event and it was like DeFi development tools. And I was a bit disappointed just because I'd rather just talk about DeFi rather than talking about, like the library I use to write tests or whatever. So I decided to like switch it up a bit. And I'll be doing like 50-50. So at the start, I'll kind of like talk about DeFi, given like an overview of the DeFi ecosystem. And then after that, I'll do a bit of like actual coding, and I'll be writing an auction contract for NFTs. So like, I'm sure a lot of you have heard about NFTs in the news and stuff, but I'll just be writing a contract where someone can put up their NFT for auction and other people can bid on it. So yeah, I guess the mandatory about me slide. I'm currently enrolled computer science at UQ. I still have 2 subjects to go, but I've haven't got around to doing them yet. So we'll see what happens there. And I work at Mycelium, and Mycelium is a company based out of Brisbane, but we're globally distributed. We have people, lots of remote workers coming out of like Britain, America, and other parts of Australia. The sort of slogan from our website is we are the vanguard building the future of fairness with blockchain technology. 3 of Mycelium's main projects at the moment are Tracer, Chainlink, Oracle, Reputation, and Secure Data Links. Tracer is the one that I work on most. It's basically a derivatives protocol on the Ethereum blockchain. It's pretty cool. By the end of, I think I don't know what the official like dates are, but by the end of October, we'll be having products on mainnet. So definitely keen for that. And yeah, I may as well go through the other 2 as well. Chainlink, Oracle, Reputation. Currently it's a website for visualizing the Chainlink network and trying to use data to derive reputation and data integrity. And Secure Data Links is a Chainlink node that the company has been operating for a few years now. So yeah, DeFi or decentralized finance. There's heaps of definitions for it. There's no like fixed way of defining it. You'll get definitions like it's anything like that exists outside of traditional sort of banking and traditional finance, which is a very general thing. And basically everything blockchain related falls under that definition. But then you get more specific sort of definitions that attempt to like reach that sort of golden standard of just having a completely correct definition. I'm not really going to like try to define it, but I mean, just in general, it's finance related protocols that exist, in a decentralized way. But I consider there to be like 2 sort of types. If you categorize DeFi in a particular way, you can categorize it into 2 types of DeFi protocols. There are DeFi protocols that sort of replicate the pre-existing traditional finance infrastructure, that replicate, banks, borrowing and lending, prediction markets and all this sort of thing. And then there's the other type, which is things that don't exist in traditional finance, but the technologies that blockchain provides allows you to, experiment with these new sorts of technologies and these new ways of like engineering finance, basically. So that's like generally like how I think about DeFi. So how I would sort of define the DeFi ecosystem at the moment in one sentence is it's more or less a global community of open source ideologues solving coordination problems and innovating. Obviously, in the context of blockchain technology. And you've got a sort of pretty cool sort of world now where, oh, Discord notifications. Sorry, James. Maybe I should have turned that off before the talk. Where each protocol is using the composability of other protocols to sort of build on top of and to further the capabilities of the technologies that are being developed. And it's pretty cool to see, and you definitely don't get that in traditional finance or even in other aspects of many other aspects of technology. So I found this online. It's sort of like a big roadmap of, not roadmap, but a big diagram of the current DeFi ecosystem. It's pretty old now, and there are some things that are not in there that should be, but it kind of gives you an idea of the kinds of protocols. You can see stable coins, insurance, lending, derivatives, and sort of how many options there are in each of those categories. So I'm just going to go through some of those sorts of categories, just the main ones that I see having the biggest influence on DeFi. The first one being decentralized exchanges. Obviously, lots of people are familiar with centralized exchanges where you can trade cryptocurrencies, but these sorts of protocols exist on chain as well, where there's no sort of company that's mediating everything. It's a peer-to-peer system designed for exchanging cryptocurrencies, usually in the context of the Ethereum blockchain. When people talk about DeFi today, generally they're talking about DeFi on Ethereum. And these sorts of DEXs, decentralized exchanges, because they're operating on the blockchain, they never stop, right? They just keep going. And for that reason, they achieve censorship resistance. And there's the security of blockchain that's inherent on these DEXs, and the rest of it, self-custody, trustlessness. You don't need to trust the DEX to operate, because it will always operate as it's encoded to. Permissionlessness, you can use it. You can set up liquidity pools as you sort of desire, as the market desires as well. And the two main DEXs are Uniswap and SushiSwap, basically, if you want to Google them. I don't know why I've got the Rari logo on this slide. That's a mistake. But yeah, if you want to do your research, you can look up the two main ones, which are Uniswap and SushiSwap. Lending and borrowing. The concept is pretty simple. You give money to a protocol if you want to lend it, and that money is used, for other people to borrow. Think of a bank. You put your savings into a bank, and then they use that money to lend to other people. Obviously, for mortgages or business loans. The difference there is that you have a for-profit, profit-taking entity, which obviously gives you between 0 and 1% APY, 0 and 1% interest on your savings, and then charges the people that it's lending to a significantly higher amount, and they take the profit. So if you wanted to sort of do the comparison there, obviously there's some pretty massive benefits. And on top of that, it's all trustless. You can set up a fuse pool in Rari, which is just one of Rari Capital's tools, completely trustlessly. You don't need a middleman to mediate it. It's all automated. It exists on the blockchain, just like the DEXs, and therefore it will never stop. The code is immutable. And it's over collateralized in general, which sort of leads to a sort of more stable base. At this point in time, it leads to a more stable base than loans in traditional finance. You could make the argument. And the three of the big ones are Aave, Compound, and Rari Capital. So they're pretty cool. Aave, I think, is the most widely used one. And then you have derivatives. So basically, derivatives are a way in general to gain exposure to a particular asset without owning the asset, I think, is the way you generally define it. You can, in that sense, provided that there's appropriate infrastructure set up, you could trade anything with a price feed. It also allows you to, enter leveraged positions. So instead of, whatchamacallit, gaining exposure that is equal to the amount of, capital that you put in, or the amount of, money that you put in to a given derivatives protocol, you can sort of extend that and sort of like double your exposure or triple your exposure, etc. And these sorts of things allow you to hedge your risk. Like there's the classic example of like if you're a farmer and you want to hedge against the risk of your crop price dropping, you can buy options, or well, you'd want to sell options in that case at to guarantee that you sell the crop at a specific price in the future. Or if you're someone who wants to use crops, you can buy futures to hedge against the risk of the crop price increasing. I don't want to make this too much of like a finance talk, and I don't really I'm not a finance guy, so I wouldn't really want to dive too deep into what futures are and options and stuff. But yeah, and obviously, got to give a shout out to Tracer here, since that's the main protocol that I'm working on, which will be, a derivatives protocol that exists on the Ethereum blockchain. So keen for that. And then there's DeFi gaming. This is something that generally I believe will explode, within the next 12 months in a, pretty large way. And you'll see themes like play to earn and the metaverse, coming into fruition. And there'll be heaps of games that just sort of like explode because they're entering this new and unexplored sort of realm of games that will sort of exist on top of DeFi. And the main one, the main DeFi sort of game at the moment is called Axie Infinity, but Aave is where it's at, to be frank. So yeah, and then there's stable coins, which are sort of like a staple in DeFi. USD stable coins being the main use case. They're essentially used everywhere when you want to use US dollars. You'll use one of the USD stable coins, which there are a couple of, namely Tether, USDC, and DAI. And then you also have stable coins which aren't necessarily pegged to a particular fiat currency, which are obviously like quite experimental. And I'm sure there's other ones, but the main one that I've seen is the Olympus Token, which basically like aims to achieve a stable coin on DeFi without it relying on the US dollar, which would be pretty cool if they can achieve that, where it's just backed by a variety of cryptocurrencies as well as some USD, and they use that to sort of like achieve a non-pegged stable coin. And yeah, so that's basically, obviously there's lots of other DeFi use cases, but they're sort of like the main ones that I would sort of want to introduce to people in a general sort of like introduction to decentralized finance. So yeah, like the talk isn't over. I'll be doing a code sort of demo to auction for a NFT auction smart contract, which I'll get into after. But if anyone has any questions, type them into the chat and I'll give them a squiz. I reckon Brayton's got a question or two. I'll just wait a minute. Oh, you'd buy puts, okay. Yeah, I obviously like carked the finance side of that, James. But yeah, you'd buy some sort of derivative. All right, if there's no questions, Brayton, mate, you've got a question. I can feel it. what's the best NFT to buy? I have mentioned a certain DeFi sort of NFT backed, DeFi backed collateral NFT based sort of game a few times here, but I won't give any financial advice on what NFTs you should be buying. Do your own research. Tell us about the metaverse. Well, the serious answer is, the metaverse is essentially like what the term that has been coined that refers to, the worlds that will exist in these sort of blockchain-based games, where you'll have land that players will occupy and sort of play the game in, but it's sort of like, a meta universe in that sense. But yeah, it'll be a pretty crazy explosion within the next 2 years or so, I would say, the metaverse games. But yeah, all right, cool. All right, so the next part of this talk, I'll be giving a little demo on how to write an NFT auction smart contract. So basically, if we have an NFT, a non-fungible token on the Ethereum blockchain, and we want to sell it, we can sell it through an auction where other players can come and bid, a token for it, and then the largest bid wins, which is like a pretty cool sort of use case. And feel free to code along with this. You should be able to follow the instructions, follow the installation and setup along with me. But yeah, so I'll just make a new directory. And then if you just go npm install hardhat, so basically you have to install hardhat, which is the sort of development environment which contains things to compile the contracts and things to write tests, and import other libraries and so on, specify the compiler version and stuff. But hardhat's sort of like one of the main ones for doing those sorts of things. I'll just wait for it to install. So the question James asked is, how do I find hardhat in comparison to alternatives? And we, the team working on Tracer, was using Truffle for ages, which is I think it's still the most popular, but probably not for long. And it ended up not really suiting what we wanted. I definitely prefer hardhat to Truffle. Just generally, it's I feel like it's more lightweight, but also the plugin support is a lot better. You have console.log in hardhat, which is like inside the contracts, which helps with debugging heaps. But there's also things like hardhat deploy and stuff, which make deployments easier. And generally, just the environment is a lot better to develop in. So I prefer it to Truffle. I haven't tried any other environments though. You have a question? Fire away. While this is installing. Yeah, mainnet forking is pretty handy. And account impersonation. But the one that I benefited most from was hardhat deploy, because we had a really slow test. We had a really slow tests, and hardhat deploy speeds that up hugely. Why am I not at the StarCraft 2 workshop tonight? Well, I haven't been to a workshop in ages, actually. Bit too busy, unfortunately. However, I would love to come one night in the future. I haven't played in general for ages. All right, it's done installing. So if you just go npx hard hat, that's the command for just setting up a project in your local repo. And then create a sample project. That's just easier because it makes the test directory and the contracts directory for you. And select the project root. Doesn't really matter what you choose here, and install the sample project's dependencies. That's just installing things like ethers and waffle for testing and chai for testing. The office internet's failing me. Can I tell you about DeFi and other blockchains? To be honest, not really. That's because of a combination of two things. A, I don't really know, and B, like generally there isn't like too much to talk about. Obviously, like other blockchains are attempting to sort of replicate the sort of innovations that have happened on Ethereum. But generally, like it doesn't extend much past that, in my opinion. Could be controversial, who knows? Can I explain sidechains and L2s? Yeah, to an extent. So there are things called layer twos on Ethereum, which are essentially a way of taking out computation from the main chain, from the layer one chain, but doing it, on a separate sort of system that still ensures the same security of the layer one. Basically using sort of like some fancy tricks with either Merkle roots or zero knowledge proofs. But it's basically like you do something on this layer two, and if it's an optimistic roll up sort of situation, then you'll the computation will be processed and you'll kind of keep going about your activities as normal, but it'll be a lot faster on the layer two, and then eventually the data will get published to the main chain in the form of a Merkle root, and then validators can come along and look at it and say whether or not they think it's correct, and if they don't think it's correct, they dispute it. And the way that the sort of like maths is set up is such that if you dispute an invalid transaction or an invalid Merkle root, it will always like succeed. The dispute will always succeed, is basically how I would summarize it. So it's basically a way to allow you to kind of get super quick transactions without and cheaper without sacrificing layer one security. I don't know, like that's obviously like a pretty quick rundown. And then sidechains are sort of like a less secure way of doing that. Sidechains came first because generally they're easier, but they don't ensure the same security. And generally, like from the ones that I've seen, they tend to have problems. But it's basically more like, I don't really know the technologies of sidechains too much, but that's how I would summarize it. Braden asks, what is a fork and what happens if a real world asset is used as collateral when a fork occurs? Do you mean like a hard fork on like a layer one hard fork, Braden? So the code set up. I'll just open a VS Code in this directory. So a fork a hard fork or like just a fork in general refers to when so the blockchain, miners, when there's an update, there'll be an update to the clients that they're running, and essentially what will happen is the blockchain new blocks will keep being generated as normal, but the update, all an update is the miners just agree to start using a new client at a particular block number, and then some miners might decide, I don't like this update, so I'm just going to keep mining on the original update, the original like blockchain. And like essentially that's what a fork is, where you have an update where all the miners start using the new update, but then maybe or maybe not, but maybe miners won't like it. For example, some miners won't like it. For example, there's Ethereum Classic, which is from back in the day. There was essentially like a hack, and that happened on the Ethereum blockchain, and it was agreed that the blocks would be rolled back. It was sort of like the first big hack that resulted in like a large amount of money being stolen that Ethereum had ever seen, and it existed on a protocol that was built on Ethereum. It wasn't a problem with Ethereum itself, but the community decided to roll back before the hack and then continue on from there. However, lots of people didn't like that because, the problem wasn't with the protocol, it was with someone who developed on the protocol, and then they decided to not roll back and keep going, and that's what Ethereum Classic is. And then to answer the second part of the question, what happens if a real world asset is used as collateral when a fork occurs? It's actually a really good question. I'd have to think about that a bit. I guess it would be like, well, if we think about something like DAI, right? DAI wouldn't it would all depend on if the actual smart contracts and infrastructure that operate DAI on the forked blockchain were still being used and there was still a market for it, in which case DAI would still exist, right? Well, I don't really understand the technology and finance behind DAI, but that's how I would see it. Whereas something more centralized like USDT, I honestly have no idea. That's a really good question. If you have some insights, Brayden, that'd be greatly appreciated. But yeah, so anyway, so it finally started installing. And then, so this is I hope this is like big enough. Maybe I need to make the text larger, which I'm not entirely sure how to do, but just let me know if the text is big enough. But this is the smart, oops, sorry. Oh, edit. Is it file? Oh yeah, it's right there. What do we reckon, 24? That's it. All right, that's big. All right, so we've got this contract here, and this is just like a default contract that is generated. The reason I'm using VS Code and not Vim is because I've got VS Code with the Vim plugin. So you could say that's like, even more like big brain of me, but like, I won't force any opinions on you. So basically, yeah, we wanted to sort of rewrite this contract. I'm just going to call it NFT auction. I'm going to give it an owner. Actually, I don't need to give it an owner. I'll just leave it at that for now. And we want a way to sort of like track the auctions. So we're going to create a struct that will like provide data for a single auction. I'll just call it owner, like the person who starts the auction, the address of the NFT itself, the token ID within that NFT. Because like an NFT itself might be unique, but sometimes you can mint like 100 of a given NFT, which will all have unique token IDs. So you need to specify the token ID in general. The start time of the auction, because you got to track like if it's going to finish or not. the current like largest bid and who the largest bidder is. Now, when people bid, they're going to like be transferring their tokens into the contract where it will sort of be escrowed. And then when the auction's finished, whoever wins the bid, they'll like essentially lose their money and get the NFT in exchange for it. So we do sort of want a way to keep track of who has bidded which amounts on each auction. So I guess first of all, we need like a way of, I see some messages coming through. And to the message retracted, that's us. So we want a way of tracking like the auctions, like auction IDs, so we can just have a counter. We also want some like variables, like how long an auction should go for, the token that'll be used to bid. And I'm just sort of copying this off like something I wrote earlier today, by the way. This isn't just like off the top of my head. And what else do we need? There's something in Solidity called events. So basically it's a way to sort of, when a transaction happens, you can emit an event, and then people can sort of scan the contract and see these events and use it as a way to tell what has actually happened in transactions. So we can add like a couple that like give some useful information about the stuff that's happening in the contract. So, you know, a useful thing for somebody to see might be that an auction has started. So then say a front end might be listening to this contract. They see an auction has started. So then they start displaying it on their front end for people to start bidding in, for example. You could say auction bid. This should really have like the auction ID on this as well. I'll just do some formatting. And you can bid on an auction. So we may as well tell people when that's happening. So you can go the amount that was bid and the address of the bidder. Oh yeah, I should probably maybe slow down a bit and explain what's actually happening. So Brayton asks, what is ERC20? So basically this will be an interface for a ERC20 token. What an ERC20 token is basically just like a fungible token on the Ethereum blockchain. So basically all the like common ones, like all of the like stable coins, like DAI is an ERC20. So the USD stable coins are all ERC20s, but also things like the Uniswap token and so on are all ERC20s. So basically, yeah, that's what that is. So that'll allow us to sort of take an address and use the functions in the ERC20 interface as a way of sort of transferring tokens around. So basically, the most used interface sort of implementation is the OpenZeppelin one. So if we import this, we can see it's importing some ERC20 Solidity file, and we'll be able to use that like throughout the contract. So yeah, I hope that sort of clears it up a bit. Yeah, so the types that I'm using, uint is short for unsigned integer, 256 bits. So that's just like the size of the number, or like rather the largest value that it can take. And address is a type that determines, that specifies a given, Ethereum address. For example, if I call a function, there's nothing here, but if I call a function and specify someone else's address that I want to transfer tokens to, it'll be able to use that address to transfer the tokens to it. So that's basically what the address type is. That's what the uint type is. And I don't think I've got any other types here just yet. The other types that exist are bool. There's other integer types. There's 128-bit integers. You can have structs like we've seen here. So in this case, we've got auction. There's bytes. You can specify how many bytes and so on. So there's a few different types going on, and there's strings. So yeah. So what else do we want? I guess we would also want, it could be handy to have a like an auction finished event, but the issue is we can't really do that because an auction will finish after a certain amount of time, but there's no way to necessarily guarantee like that, the smart contract will be operating during that time. Like we would have to call a function at the time that it ends to trigger that event. So we're not going to add an event finished auction finished event. So if there's anything else that we want, so we want to track for a given auction, we want to track how much each person has bidded or has bid. For example, if person A bids $10, person B bids $20, person C bids $30, we want a way of saying person A got outbid. So how do we actually guarantee that that person will be able to reclaim their tokens that they have bid with? So a good way to do that is basically using a mapping. So a mapping is basically like a map in like Java or whatever. It essentially operates the same way. So you can have something like a mapping of uint to address or something like that, where you can populate this mapping and then use the uint, the unsigned integer, as a key that has been populated and access a given address. Or in this case, we can have a nested mapping, which will basically sort of operate like this, where we can call it user amount bid. And in this case here, we would want this mapping to be used where you give it for the first parameter an auction ID, and then it returns a mapping which takes like a bid address, a bidder address, so somebody who has bid in the auction, and then the amount bid, so how much they bid. Now this is useful, so when someone gets outbid, they can call a function and basically claim back the amount that they have bid, because obviously we don't want the contract to keep their tokens if they lost the bid, if they lost the auction. And then also we want a way of actually keeping track of all the auctions. So we'll want a mapping that goes from auction ID to the actual auction itself. So yeah, so then they're all the sort of variables we'll need to actually operate the auctions. Now we just have to add the functions in. Cool. So I'll just delete these functions because they're not needed. And the constructor will need to change. So a constructor is basically when the contract is deployed to the blockchain, it needs to be passed in certain data to the constructor. Obviously, not all the time it can have an empty constructor, but we'll basically want to, I'll just sort of collapse these. We will want to pass it certain parameters. Namely, we want to pass in the actual token that's used to bid, and the the length of the auction, so how long an auction can actually go for. I'll just add a comment here. We'll make that in seconds. Now with blocks on the blockchain, it's not guaranteed how long they'll actually last for. For example, you know, one block might last 12 seconds, the next might last 13 seconds, and therefore the block's timestamp isn't necessarily 100% accurate, but in general, like, it can be safely used for certain situations. And we'll just use it here, since this obviously won't be going into production. So then all we need to do now is just like, you know, instantiating a class in Java. We just set these values as they're given in the constructor. So bidding length, bidding quote token equals the one that's given in the constructor. So that's the kind of setup for once it's deployed. And then what we're going to need to do, obviously, we're going to need a function where somebody can give their NFT to the contract and say, put this up for auction. So we're going to do that with a function called start auction, where it takes the NFT itself that's supposed to be put up for auction, and the ID of the token. So again, that's because an NFT might have multiple like tokens within that NFT address, if there were multiple that were minted. And we may as well add a function called, a parameter called the floor, where the auction starter defines where to bottom it out, like where to start the auction at. So then I can try to deploy it to a test net. I didn't really anticipate that I would have enough time, but I got the first bit done like pretty quickly. I do only have 17 minutes left. What I was more going to do, just as like a time-saving experiment or like time-saving activity, was write tests instead that sort of replicate how it would be used and how the functions would actually be called. But unfortunately, that would just be like locally. If I do get enough time, I might try to like set it up, but it might be too hard since I didn't prepare for it. So then like the auction starting function, we're going to need to transfer the NFT basically, if we sort of like add a bit of a comment here. But we want to transfer the NFT to the contract itself and start a new auction, right? Now to transfer this NFT, we have to actually like be able to utilize the non-fungible token interface. And to do that, we essentially have to do the same thing as what we did, as what we're going to be doing with the bidding quote token. Hold on, I just found a bug. We actually need to cast this to ERC20. So we get the address of an ERC20, and then we make it just sort of like conform to the ERC20 interface. So essentially what we're going to need to do is, so the ERC20 defines a fungible token. ERC721 is for a non-fungible token. So we need to cast this NFT address to a non-fungible token and then transfer it from whoever's sending it. So message.sender is the parameter given to whoever starts a Ethereum transaction. It's just sort of like one that always exists within a function call. And we want to transfer it to this address, and we want to transfer the token ID that's specified. So much like this import here, we want to use the interface that's made by OpenZeppelin. But we want to use the ERC721, which is the interface that specifies a non-fungible token. What else always exists in a function call? There's a few things that always exist. We'll be using one shortly that is block.timestamp. There's also tx.value, I think is what it's called, which specifies how much ETH was actually given to the transaction. There's also, I think, tx.gas limit, which specifies the maximum amount of gas to use in a given transaction. I think that's what it is. Like, I think it's called gas limit. But yeah, I think that's like, they're the main ones I've used, but I'm sure there's like heaps of, well, I know there's heaps of others, but I just never use them. So I can't remember off the top of my head. So yeah, so we got the ERC 721 interface, and we want to transfer that to the contract itself. And then basically we want to populate. So we've got this auctions mapping here. And we want to populate that at the current counter. So then we can go like here to make a new struct, a new auction struct, where the owner is the person who's starting the auction. I think that's common. The NFT itself is the NFT address given by the user. The token ID again is the token ID given by the user. And the max bid, like the current max bid, is whatever they specify the floor to be. So that'll just be like, you know, people have to bid more than that to get the to make a successful bid. And then we need to specify the start time, which is useful for determining if the auction has ended. And that's basically all you need to do. And then you have to increment the counter, obviously. So yeah, and then after that, there'll be an auction that is added to the auctions mapping that started at this time here, and is for this NFT with this token ID. So then if we want to like see if this compiles, I'm sure I've like, you know, left out a lot of things, but we can run npx hardhat compile and see what happens. Oh yeah, we have to install OpenZeppelin contracts, and also I may as well rename this file NFT auction. So to install these OpenZeppelin contracts, being the ones that I've imported up here, we basically just have to npm install at OpenZeppelin/contracts. We'll see what happens. Okay, so it installed, so hopefully like we'll get a bit more progress here. And some syntax errors. Okay, yeah, I wasn't sure about this. Yeah, so it's all comments here. No, except for the last one. And I've left out something in the auction struct. Oh, and the max bidder. So the max bidder, since there hasn't been one, we will just set it to address 0. And I did a semicolon again. Oh yeah, and we have to specify functions visibility. So we just do that at this part of the function. So the function keyword, then the function name, then the parameters, then the visibility. Pretty much the same as lots of other languages. And it compiles. Cool. So then basically, so then we want to create a new function that allows us to bid on an auction. So the auction has started, but we want one to bid on it. So then we would specify here the auction ID, the bid amount, and what else do we need? I think that's it. And for this visibility, we may as well make it external, since nobody, only external calls will be made. The external keyword means that only things outside of this contract can call it. So no other function inside this contract can call an external function within the same contract. There's external, public, and internal, other three visibilities. So yeah, so then the bid function is going to, it's going to make sure first of all that the auction hasn't ended. So we can use this require keyword, and basically it's like require some Boolean value, and it requires it to be true, and then error message is like the general format of it. So we want the auction to not have ended for a bid to be successful. So I'm going to just add this here, which we haven't defined yet, but I'll go ahead and add it down here. And this can be internal because we may as well make it public in case someone wants to call it. So then basically what we want that to do is we want it to fetch the auction from the auctions mapping and get the start time. And then we want to basically make sure that the current time stamp of the current block has surpassed the start time plus the length of the auction, which basically means that the auction has been going for longer than the start time plus the auction length, if that makes sense. So basically, if you bid, you want to make sure that the auction has not ended, and we can say auction ongoing. Auction has ended. And then then basically what we do is, so if you're bidding on an auction, you want to make sure that the, well, we may as well, so what we can do now is copy the auction into memory so we can keep reading from it relatively cheaply, because it exists in storage without copying it into memory, and reading from storage every single time will be quite expensive. So we have this little trick here. And then we want the auctions like max bid. We want to make sure that amount is greater than the max bid. And we can just say it's too small if it's not, because we only want the bid to be increasing, right? The bid amount. So then what we can do is basically like bidding quote token dot transfer from, we want to transfer the quote token from the message sender to the current contract address. Now we can't just go amount, the amount that's specified, because what if this user has like bid before in this same auction, they've been outbid, but they haven't necessarily like claimed their tokens yet for being outbid. And then if you just keep like transferring the amount that they've bid, the amount that they pass in, like you may as well just like increment on top of their previous bid, if you know what I mean. So we can basically like I have a variable called amount previously bid, which looks at like the user amount bid mapping, which is the one that we defined up here. That goes auction ID to bidder address to amount bid. So we can go auction ID and then message.sender. So that's how much they have already bid. And then the amount to transfer can be calculated as amount minus amount previously bid. And then the amount to transfer is how much you want to transfer in that case. If that makes sense. So then what do you want to do? You want to basically, you want to set this new like users bid amount to be equal to their new, like their latest bid. And remember, this is for keeping track of like how much they've bid so they can reclaim it. And I'm like pretty quickly running out of time here, but we'll see. And basically, you want to change the so you want to change the max bid amount and the max bidder in the auction. So you can go auction ID dot max bid to be amount, and then max bidder to be the person sending the message. And then basically I might not have enough time to like write the whole thing, or even like obviously I'm not going to have enough time to write the tests. I don't know if I'm like allowed to go over time, but oh, it is sweet, cool. So basically, so once an auction is finished, and to just sort of put it into perspective, what should I call it? When a user gets outbid, they want this function here, claim outbid tokens, which will be external, and that'll essentially allow a user to, like when they're outbid, reclaim their tokens. So the contract gives them back their tokens because they didn't win the auction. And then once an auction has actually finished, we want to process it. So we want to transfer the NFT to the person who won the auction and transfer the ERC20 tokens to the person who held the auction. So we need the auction to be ended. So we can use this auction ended function that I wrote before. And I'll need to put the semicolon down there. And then, so if it hasn't happened, then the auction is ongoing. And then basically, so then what happens here? So you want to, what do you want to do here? First of all, you want to transfer the ERC20 token to the person who won. So then you can get this auction again and copy it into memory. And then the auction NFT, we want to safe transfer from, well, we have it, so we can just transfer it, but I'll put address.this into auction.maxbidder. So they're the person who won, and the auction's token ID. And then basically you want to bidding quote token, the token, you want to transfer that from here, from the contract address to the person who held the auction, which basically looks like that. And then I don't know if there's any, I've got here, like I've written a few other things, but I don't think anything else is really necessary. Oh, yeah, so you will have to So the user amount bid, we don't really want them to be able to, so just for extra safety precaution, we don't want them to be able to transfer out their bidded tokens because they've won the auction. But we would obviously account for that in the claim out bids token. But just in case, we want to set it to 0 so they can't do anything else. I'm making a vulnerability static analysis detection tool for smart contracts. Oh, cool. Yeah, so as Chris said in the chat, you'll need ERC20 approval, which is an external thing, but it basically means that before calling this bid on auction function, the bidder is going to need to approve this contract to transfer the bidding quote token on its behalf. So obviously, like, it would not make much sense if you can just like transfer tokens from anyone to anyone else. Yeah. So you need to approve it, basically, is what I'm trying to say. Yeah. Aiden, I don't know if you can, you're not checking your Discord, but can you bring my charger, please? Because my laptop's about to run out of battery. Classic DOS, not checking Discord. So yeah, that's basically like, I think all process finished auction needs to do. And then we need to claim outbid tokens. So when you're outbid, you want to be able to claim it. So what you need to do here is, well, I guess like, yeah, the same thing. You need to make sure that the message.sender, the person actually claiming, isn't the current winner. Because if they are, then they haven't been outbid. Yeah, and then you need to calculate how much they actually need to withdraw. Oh, here it is. Cheers.
What do you want?
I'll plug it in. Yeah, that's all good. Sorry about the interruption. So when they're outbid, the amount that is withdrawn is actually going to be taken from the user amount bid as usual to get the amount that they've bid, pass in the auction and the person sending the message. And then basically you transfer to that person the auction ID. You transfer to message.sender the amount to withdraw is basically what happens. And then really like, I think that's it. And also you need to update this amount bid. You just set it to 0. And that's all you really need to do for that. So that's basically like the contract. I've already gone 5 minutes over time, but essentially, like, if you want to write tests for this, it would be pretty easy, because like as, which is the one of the things that hard hat provides, I'll just like copy and paste it, is like pretty good for deploying contracts locally. So you can see here, you actually don't need to import it, but you can see here the template test just deploys from a factory, giving the constructor arguments. The chat's ended apparently. And then you just call the functions just like this, right? Like the template contract that we saw before had the greet function. And you can literally just call it like this, and then it'll call it as if it was like a real blockchain sort of transaction, but it's all just happening locally. But I won't go like too far over time and write those tests, but yeah. I'll upload this code as well if anyone wants to like have a squiz. and obviously don't use this in production because it's probably got vulnerabilities. But yeah, so that's that. Apparently the chat stopped, but yeah. Oh, the chat's still going. I don't know. Someone messaged me saying it stopped. But yeah, I'm not sure. Yeah. All right. But yeah, so that's basically like how you would write like a very naive auction contract. There's actually something called a GBM auction, which is sort of like when you're outbid, you're paid a little bit by the person who outbid you. And it's sort of like an incentivized bidding like auction scheme. Yeah, but this is like a very naive sort of I've forgotten the name of it. It's not Dutch auction, the other one. Or maybe it is Dutch auction. I can't remember. But yeah, so that's like pretty much it. If there's any questions in the chat. What are some vulnerabilities you need to watch out for? So like the main one that you'll sort of learn when you first start learning about smart contract vulnerabilities is something called a reentrancy attack. And that's basically when you call an external function in a smart contract function and then update the state afterwards. And what that essentially leaves open as an attack vector is if this external call has like sort of something in it that would allow the function to call another function on that smart contract, the original caller, it would be able to modify the state in a way that doesn't take into account, that takes into account the fact that the state should have been modified, but it hasn't. So it's sort of like it re-enters the contract before the state gets modified and sort of like is able to manipulate the state of the contract in that sense. So that's probably a really bad explanation for a re-entrancy attack. That's sort of like the main smart contract sort of blockchain exploit that you sort of learn about at the start. There's also like a lot of tricky things to do with like contract ownership. And Matt has just like absolutely pulled through and given a checklist. Securium is a good place to look at, the Securium Substack, if you want to learn more about smart contract vulnerabilities. But yeah. So yeah, if there's any more questions, shoot them through. I think the chat's still going, Chris, if you want to ask any questions. But yeah, I'll just wait a bit. I may as well just copy and paste the tests that I wrote here and show you them. So this is like the single test case that I wrote. It's basically, oh, thanks, Arthur. I hope you did. Basically, it deploys the contracts. It deploys an ERC20 token contract, and then deploys the NFT auction contract, deploys an NFT, mints the NFT, starts an auction, and then just simulates a bunch of bids. You can see the approvals here for the token transfers, then processes it, and then the loser of the auction can claim their outbid tokens. And then these are the balances that they end up with after they've been given these amounts. But yeah, I won't go too much into it. Yeah, as Madhav says, like there's the technical vulnerabilities, but I feel like the majority tend to be like economic. And as Madhav says, like they're a lot harder to sort of like reason about. Like there's no rules for preventing, you know, like an economic vulnerability or a vulnerability that exploits like a weak governance system, right? If you know what I mean. There's no sort of like, I don't know, library to protect against it. So you really just have to have like a deep understanding of the protocol and how it's going to be used to sort of avoid those sorts of exploits. And yeah, and as like the composability of everything increases and everything gets like exponentially more complex, these sorts of things just sort of like you know, it's very hard to just completely stay on top of them. But yeah, that's basically what Matt have said. So yeah, if there's no more questions, I'll end it there. And direct.news. Yeah, that's like a good place to go.
All right, sweet. Thanks so much, Ben, for that talk. It was really good.
No worries.
So
Thank you.
in terms of future UQCS events, we have a talk next Tuesday, version control and you with Jenna McDonald at 6 p.m. and that will be online again. No events in person next week. But until then, thanks so much for coming. And we hope to see you at our next event.
Cheers. See ya.